Before we discuss remainder and factor theorem, let's first discuss the division algorithm for polynomials. It says that, suppose p is a polynomial function, then if p of x is divided by x minus r, we obtain as a quotient a unique polynomial q of x, and as a remainder a real number r, such that for all values of x, the polynomial p of x is equal to x minus r, which is the divisor, times q of x, the quotient, plus the remainder. Actually, galing lang din siya sa pag nag-divide ka ng numbers. For example, if you divide 7 by 3, for example, the answer is 2, remainder 1. And then you can express 7 as 7 equals the divisor, which is 3, times the quotient, which is 2, plus the remainder of 1. Okay. Now, let's consider the first example that we have earlier. Nung diniscuss natin yung kung bakit gumagana ang synthetic division. So, consider x cubed minus 4x squared plus x minus 10 divided by x minus 2. Actually, ito na yun. Nagawa na natin yan. So, according to the division algorithm, we can express x cubed. Palakihin lang natin yung font. So, we can write x cubed minus 4x squared plus x minus 10. This is equivalent to the divisor, which is x minus 2, times the quotient, which is x squared minus 2x minus 3. And the remainder of minus 16. Okay, so that's it. Gamitin natin to, division algorithm, sa pagpuprove ng remainder at factor theorem. Let's first have remainder theorem. If the polynomial p of x is divided by x minus r, dun sa division algorithm, normally may mga libro na instead of x minus r, it's d of x para maging general lang yung divisor. But for us, we'll just consider the divisor, we'll just consider a case where the divisor is of the form x minus r. So if the polynomial p of x is divided by x minus r, the remainder r is a constant and is equivalent to p of r. So, ibig sabihin, p of r is equal to the remainder. So, we have to show this. So, let's write the proof. Now, yung proof natin magagaling sa division algorithm. By the division algorithm of polynomials, we have p of x equals x minus r times the quotient q of x plus the remainder r. Okay. Then we have to get p of r. Kapag kinuha natin p of r, ang mangyayari dito, lahat ng x papalitan natin ng r. So it's equivalent to r minus r times q of r plus r. And in that case, p of r, yung r minus r, 0 na yon, 0 times q of r, kung ano man yung q of r na yan, plus r. Thus, we have p of r is equal to r. Let's apply the remainder theorem. Okay, this is example number 4. Find the remainder r when x to the 4th minus x cubed plus 2 is divided by x plus 2. You can show this by either using this remainder theorem or using the synthetic division. Let's use both. But first, let's use the remainder theorem muna. Okay, in order for us to use the remainder theorem, kailangan, ano muna to? I-express natin yung x plus 2 in the form x minus r. So, kailangan yung x plus 2, i-express natin in the form x minus r. So, this can be written as x minus negative 2. So, in that case, r is equal to negative 2. So, by the remainder theorem, ang remainder nito, kapag dinivide siya sa x plus 2, is equivalent to p of negative 2. And let's substitute negative 2. We have negative 2 raised to 4 minus negative 2 cubed plus 2. And negative 2 raised to 4, that is 16, minus negative 2 raised to 3, that's negative 8, plus 2. And we'll get 16 plus 8 plus 2. And 16 plus 8 plus 2, that is 26. 26. So therefore, the remainder is 26. Let's verify this using synthetic division. We have negative 2 here. And then the coefficients. This is x raised to 4. And if you'll notice, wala tayong quadratic term. So we'll add a 0. So we'll have 1 for x to the 4th. Minus 1 for the x cubed. And then 0 for the quadratic term. We don't also have a linear term. So we'll also add a 0. And then we have a 2. So bring down 1. 1 times negative 2, that's negative 2. And then we add minus 3. Minus 3 times minus 2, that's plus 6. Bring down 6. 6 times negative 2, that's minus 12. And then we'll have minus 12 here. And then minus 12 times negative 2, that's plus 24. And then 24 plus 2, we have 26. The last number here is actually your remainder. And it verifies the remainder theorem. We have example number 5. Find the remainder r when 5x raised to 2000 plus 2 is divided by x minus 1. Let's not use the synthetic division. Dami nito. Okay, let's use the remainder theorem. So by the remainder theorem, our r here is 1 because x minus 1, x minus r. So r is 1. And the remainder is equivalent to p of 1. So that's equivalent to 5 times 1 raised to 2020. Ano pa yung sabi ko kanina? 2020 ba yung sinabi ko? Plus 2. Parang 2,000 lang natin sinabi ko kanina. Equals 5. 1 raised to 2020 or 2020. That's just 1. Plus 2. And the answer is 7. So the remainder when 5x raised to 2020 plus 2 when divided by x minus 1, the answer is 7. So the remainder is 7. Walang dayan. Let's have example 6. When divided by x minus 2, kx squared plus 5x minus 2k yields a remainder of 4. Find the value of k. So in this case, since the divisor is x minus 2 is already in the form x minus r, so r is equal to 2. And then if we determine daw the remainder, which is p of 2, equal daw yun sa 4. So let's determine p of 2. P of 2 is equal to k times 2 squared plus 5 times 2 minus 2k. And this is equivalent to 4. So we have 2 squared times k, that's 4k, plus 5 times 2, that's 10, minus 2k equals 4. Let's combine like terms. We have 4k minus 2k, that is 2k, equals 4, and then we put 10 to the other side. You have minus 10. So you have 2k is equal to minus 6, and therefore k is equal to minus 3. So the value of k when kx squared plus 5x minus 2k when divided by x minus 2 yields a remainder of 4 is negative 3.